Hello guys, welcome to the channel. Today we will discuss KNN algorithm for classification. So first understand what is KNN, K nearest neighbors. K nearest neighbors is a supervised learning algorithm used for classification and regression both. For classification predicting categories or classes and for regression predicting numbers, right? In KNN classification, for classification, the model predicts the class of a new data point by checking the nearest data points around it. What it means. Suppose I will explain you by a real life example. Suppose you have two fruits, apple and orange. Okay. Now you get a new fruit. Okay. But you have to predict in both of these two. Okay. Now which fruits we will check by KNN which fruits are closest to this new fruit. Okay, apple or orange. Okay, suppose if most nearby fruits are apples, okay, to our new data point, then model will predict apple. And if my most nearby fruits are oranges to my new data point, then it will predict orange. Okay, so this is how a graph, an example of graph where I have two categories, 0 and 1. And this is how it tries to extract the same categories by calculating the distance between these data points. Suppose this is 1 for green, 0 for red. So you can see some red are there in green part also. Okay, but what it is trying to do is it is calculating the distance between the data points, each data points. And for closest data point, it tries to extract them together. Okay. Means it is categorized different categories on the basis of their distance. Okay. So greens are almost close to each other, reds are mostly close to each other. So this is how it basically classifying the categories on the basis of the distance. Okay, so main idea of Canon is similar things stay close together. Okay, this is what I explained in the graph. KNN works completed based on distance. Okay. It finds nearest neighbors on the basis of the distance. Check their labels or classes like 0 or 1. Any classes. Any kind of classes. Choose the majority class. Okay. So this is what I explained in the graph, and this is what the in theory main idea of KNN. Now we will check how we can do it, how we can perform KNN for classification problem practically. So this is my data set. Okay, this data set I have used previously also in my previous video also. So on this data set, I will try to perform my KNN algorithm. This is the kind of classification problem because I have only two categories, like two categories, or I have categories not like I have uh, continuous values like regression. So it is a problem of classification. Now we will see how we can perform KNN on this data set. Okay, so first I will import some required libraries. NumPy as np, import pandas as pd, import matplotlib dot pyplot as plt, import cborn as sns. Okay, now I have imported all the required libraries. Okay, so now I will load my data set equal to pd dot read slash csv because I have csv file. If you have Excel file, then you can write Excel. By the way, I'm giving the data set for every video. Okay. So this is my data set. I will right click, copy path. I will paste it here. I will check my data is loaded or not by checking its first three rows. Yeah, my data gets loaded and these are its first three rows. Now, now I will show you how my data is spread through a graph. Okay, now I will plot a scatter plot. I will give x is equal to age. I will give y is equal to estimated salary, and I will give data is equal to data because in data variable I have taken my data set is equal to I will give purchased. Okay, now plt dot show. Now you can see how my data is spread. Okay, this is how my two categories, 0 or 1, purchased or not purchased, is looking like. Okay, so we will see at the end by plotting a graph again how my data gets separated using KNN algorithm. Okay, we will see that. Now, first I will divide my data set into input and output. I will take all input columns in X and all my output column into Y. Data.ilog. So what are my input columns? Sorry, my all rows, my all column, but don't give me the last column because last column is my output column and these are my input columns, age and estimated salary. Okay, so I have taken X, all input columns into my X and I will take output column into Y. Okay, Control C, Control V. Now my data gets separated into input and output by X and Y. Okay, now I will standardize these age and estimated salary columns. Okay, because you can see here age has lower values 1935 and estimated salary, obviously estimated salary will have more higher values. So my model will give more importance to estimated salary, which is wrong in our case because both columns are important for me. Okay, so I have already covered how to perform standardize in detail. So I will perform standardize standardization sklearn dot pre-processing import standard scalar. Okay, yeah. Now suppose I will make an object to call standard scalar. Standard scalar. Okay, now I will fit my x into standard scalar because only input columns I want to standardize. Okay, so control sorry x I fitted. Okay, Now I will transform it into columns. Okay. X is equal to PD dot data frames frame SC transform SC transform form X columns is equal to X dot columns. Okay. Now, I will show you the X, so you can see here my I have performed standardization, so you can check the values now. Okay, look at here and look at here. Okay, I have standardized my input columns. Okay, the data of input columns. Okay, now now I will split the data set into training data set and testing data set. Okay, for that I will import train test split scalar dot model selection import train test split. Okay, now I will take my all four variables x train, x test, y train, y test is equal to, I will call my train test split for which variables x and y. I have taken input and output columns into it, x and y. Now I will give test size is equal to 0.2 because I want 20% my for my testing data and 80% for my training data. Okay, random state is equal to 42. Okay, now my data gets split into training and testing data randomly. Okay, now I will build a model using k nearest neighbors, k nearest classifier because this is a problem of classification. So now we can make it from sklearn dot neighbors 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 import k neighbors classifier k neighbors neighbors classifier. Okay, because this is the problem of classification. Okay, now suppose I will make an object to call my k nearest classifier. Now if you remember, in our decision tree, we used a parameter max depth. Okay, max depth we choose 3, 4, 5, anything. Similarly, in nearest k neighbors classifier, we can choose n neighbors is equal to 3, 4, 5. Suppose I will give neighbors n neighbors is equal to 3. What it means? Means I'm saying that look at three closest data points. Look at the three closest data points. Okay. That's what I'm saying by giving a parameter n neighbors is equal to 3. We can give 4, 5, 6, anything. Suppose I'm giving 3. Okay. In decision tree we saw we gave max depth is equal to 3. Suppose I'm giving n neighbors is equal to 3. Now I'm saying that look at the three closest data points. Okay, that's what I'm saying by this line. Now, I will fit my training data into it. KNN dot fit. KNN dot fit. X train and Y train. Okay, it gets fitted. Now, suppose I will check accuracy of my model. X test, comma Y test into 100. Now, 91% accuracy I'm getting. Okay. Now, now I will show you by plotting a graph how my data is getting categorized, how my data is getting spread. Okay. I'm plotting a graph. Okay. From ML extend. If you have not ML extend, I have already shown in my previous video while covering decision tree for classification, how we can install ML extend. Only pip install ML extend. You want to give command in your CMD and it will install. It will be installed. Okay. Dot plotting import plot decision regions. Okay. Now I will call this plot decision regions. Now we have to convert it into numpy to numpy. Also for y dot to numpy, and we will take CLF is equal to KNN, right? CLF is equal to KNN. Now I will write PLT dot so. Now, now you can see how it tried to basically categorize my both features or both classes or we can say labels. See, this is 0 for blue and 1 for this orange one. Now you can see some blue points are also there in my orange part, but it tried to cover that also. See here. Okay. So this is how it tried to split my categories or classes according to their distance. Okay. So this is how KNN for classification works. Okay. So in the next video, we will see how KNN works for regression problem. Okay. So that's all in this video. Thank you.